Hello, everyone. I'm going to take questions off of Friday's assignment today and tomorrow. So during the Zoom meeting, which I will hold tomorrow, please make sure that you guys join. Let me know what questions you have. You could email them to me first. That way I'm ready to go over them. If not, just have them, any questions you have ready for me tomorrow during the Zoom meeting. All right, so we're still in section 1.5. Now let's kind of just rewrite the 3 laws of logs that you guys had in your Trig Essentials packet. So pause the video and write out what you remember, and let's do them all for log base b. So I'll kind of get you started here, and then you can pause the video and write them out in expanded form. So if our first expression starts as log base b of a times c, go ahead and expand that. And then for the second law, it's going to be log base b of a divided by c. And then third, we'll have log base b of a to the power of c. All right, so let's see what you were coming up with for expanded form. So with exponents, the operations of multiplication and addition are always linked. So this will become an expanded form log base b of a plus log base b of c. Division and subtraction of exponents, those divisions of powers with like bases, we subtract the exponents. So those operations are always connected. So here we're going to have log base b of a minus log base b of c. And then we were using this quite a bit with solving exponential equations. Missing exponent, then we always try to take the log or natural log of each side of the equation, and then that allows us to bring our exponent down in front. So this becomes c times log base b of a. So we have to keep those laws of logs in mind. All right, one of the examples we looked at on Friday was the inverses of logs and inverses of exponential functions. So logs and exponents are inverses of each other. So if we were looking at like a log base 10, so we found that our inverse was that y is equal to 10 to the x, because we could start with this and rewrite it exponentially. So this becomes, we have a log base 10, so this is 10 to the power of y is equal to x, therefore making the inverse y equals 10 to the x. And we looked at this graphically as well. So now we could say we have this at any base. So now if I give you y is equal to 3 to the x, go ahead and find the inverse of f. And we could start this again by switching the x and the y, and then rewrite this logarithmically. So this will just become log base 3 of x is equal to y. So that would be our inverse because it's already solved for y. So we would say, therefore, y equals 3 to the x, and log base 3 of x, or y equals log base 3 of x, are inverses. We could even go up here and say y equals log base 10 of x and y equals 10 to the x are inverses. So now we could generalize this, which we do a lot in this class. So now we could say y equals a to the x, and then y equals log base a of x are inverses. So anything of these forms will be inverses. All right, so we're going to apply this to natural logarithms as well. So algebraically, go ahead and find what the inverse of y equals e to the x is. There's actually a couple ways we can continue from what we just did on the last page as well. All right, so if we were to look at this and just switch the x and the y, we would get x is equal to e to the y. And then what we could do is take the natural log of each side, because we want to solve for y. So we get the natural log of x is equal to the natural log of e to the y. And then this brings our y value, our exponent, down. So the natural log of x is going to equal y times the natural log of e. Now, what is the natural log of e again? What value? That's just 1. So now we have our inverse is just y equals the natural log of x. Or if we were to look at this just using logarithms and not the notation for natural log, we could rewrite this and say log base e of x is equal to y. Well, this right here, log base e, is the natural log of x is equal to y. Therefore, y equals e to the x and y equals the natural log of x are inverses. So this looks just like what we wrote off on the last page here, except when a is equal to e, it's just the natural log. We don't have to write it because remember, log base e is the natural log, ln. So we're just applying it to the specific case. All right, so we're going to use these properties here to help us solve and check. Again, we were working with investments, principal amounts, population increase and decrease that had us using logs and natural logs. These are pretty much the same thing. They're still exponential equations when our variable's in the exponent location. So we're just going to go through and use inverse operations to solve. Again, we want exact and rounded to 3 decimal places. So if we start with 4 times e to the 2x minus 3 is equal to 35, first what we want to do is divide both sides by 4. And again, we could leave 35/4 just as it is until we get down to the very last step of approximate. Or again, you could separate it, log 80 divided by log 5 all over 3 minus 2/3 as well. But again, that's the approximate form or the exact form. And then x is approximately, so this is our exact form. Go ahead and type that into the calculator and see what you're coming up with. Pause the video. And we should be getting 0.241. All right, so just a few more questions. Again, these equations weren't pertaining to any kind of specific exponential or modeling equation for exponential growth or decay or interest, compounded interest. All right, so again, be ready with questions tomorrow off of Friday's assignment. Go back and correct them. Here I have a short gift, 1.5, 1 through 10. And then next Monday, I'm going to give you guys a test over 1.3 to 1.6, trig essentials, the natural log, and e-gift as well. As always, our tests are going to be part with a graphing calculator, part with no calculator. As the week progresses, I will give you details on what kind of questions, how many points the test will be worth. All right, so I'll post this as a separate PDF as well, or you guys could just keep the video paused here and copy the problems down or take a picture of this and work on the 1 through 10 here.